Hi, my name is Jan Wilczek from WolfSound.com. Welcome to WolfTalk, a podcast about audio programming. In this podcast, you will learn how to build your career in programming or research related to audio, meet programmers and researchers from all around the world, and learn about the intricacies of sound. Hi everyone, and welcome to the 22nd episode of the WolfTalk podcast. Today I have a very special guest for you, namely Gustav Andersson. Gustav is a senior C++ audio developer in Elk Audio, a company based in Sweden. He's recently given a great talk at the Audio Developer Conference 2023, where he explained in detail how to guide the compiler to optimize your DSP code for you. I enjoyed the talk a lot. It made it to my top 10 talks, so I'm super excited that Gustav made it to the WolfTalk podcast. Gustav is mostly responsible for the Sushi digital audio workstation at Elk Audio, and he also worked extensively on their Elk Live software, so software that allows musicians collaborate on the network live, which is, I think, very, very cool. So we'll discuss his path, how he got into the audio industry, and believe it or not, he really wanted to get in there, and also how he, learned all the necessary tools along the way. Of course, we'll mention a ton of tips and resources, which are all listed in the episode notes at dwolfsound.com/talk022. Once again, it's dwolfsound.com/talk022. If you'd like to support the podcast somehow, there are 3 ways how you can do it. Well, you can subscribe to the YouTube channel and hit the thumbs up over there. The second way, you can give a 5-star review if you believe the podcast is good, for 5 stars on Apple Podcasts or Spotify. And if you would like to propose someone as a guest for the next podcast episode, you can do so in the comments on YouTube or in the episode notes. And if you would like to become someone like Gustav, someone in the audio industry, an audio developer, you may say, then please check out my free resource, the Audio Plugin Developer Checklist, which lists every bit and piece of knowledge that I believe is necessary to learn audio programming and to become a full-fledged audio developer. You can find it at dwolfsound.com/checklist. And now, Gustav Andersson. Hi, Gustav. Thanks for agreeing on this interview. Could you please introduce yourself to the audience?
Oh, hi, Jan, and thanks for having me. Who am I? My name is Gustav Andersson. I'm an audio developer living in Stockholm, Sweden. Originally from Gothenburg on the west coast of Sweden, but have been living in Stockholm for over 10 years now. I am occasional musician, runner, a father of a 2-year-old, generally interested in sounds, like anything that makes sound piques my interest. I'm working for a company called Elk Audio here in Stockholm.
And how did it start with the interest in sounds then?
I think that started very, very early. I was playing my first instrument was the trumpet back when I started when I was like 8 or 9. But then I think around like 12 years old, something, I discovered that you could make music on the computer. Like you had these trackers on my dad's Amiga, and that was really fun. But to me, I think it didn't start until I always thought that and playing the trumpet was kind of 2 different worlds. It was like when I was playing the trumpet, I was going to lessons, I was going to band practice, and I was playing the parts, but I didn't play anything outside of that, or I didn't improvise anything. It wasn't until a few years later when I stopped playing the trumpet and I started playing the guitar instead. which I thought was more fun. But then it kind of merged a bit because that was something that I was interested. I did it because I wanted to do it, and immediately I got into like pedals and stuff, and just interested as much as playing into the kind of sounds you could make with the guitar. And then eventually I got into synthesizers and started building guitar pedals and synthesizers and stuff, and that's what's eventually led me towards studying electrical engineering at university.
Okay, and which university was this?
Chalmers.
Oh, okay.
In Gothenburg, where I grew up. I think it was interesting because I got into uni because of my interest in like building fuzz boxes. So I was interested in the sort of analog electronic side. But once in uni, I could have drifted more towards programming and more towards the digital DSP and things. So I did a master in signals and systems.
Okay. And like before we went to the university, were you also playing in some band, or were you releasing the music somehow?
I did some self-released stuff on like MySpace and things. I was also playing in bands a lot. My brother plays the drums, so he and I have played a lot together in several different bands. But I played in bands up until I was 30 and moved to Stockholm, basically. So I've always had the kind of being in bands and playing the guitar or bass, but also doing like electronic music by myself. So I've always felt like I have like one foot in the indie world and one foot in the electronic world.
And those analog units that you built, were you also have you also started selling them, or were you building them for yourself?
No, I was just building them for my own. I never really thought about starting a business because I wasn't really interested in that. But I think definitely my interest in analog electronic was very sort of helpful in both in sort of directing me towards which field of engineering I would go into, and what also when we were talking about filters and things like that, it was easier for me to relate to what is a low pass or high pass filter and things like that.
Okay, I understand. And how did you go about building those analog units on your own, like without, let's say, formal education? So did you find the schematics somewhere that you mimicked?
I found some schematics. I think I bought PCBs mostly of like existing units or clones of like classic pedals. Eventually, but sometimes they didn't work, and I was like, how can I troubleshoot this? How can I debug this? Because I didn't understand what a transistor does and things like that. So that's what sort of led me into electrical engineering. But then being there, I kind of thought programming was really interesting, so drifted more towards that. And after uni, I got a job as a developer. So that's when I started coding.
Okay, and could you just maybe briefly reflect on the university course? Because believe it or not, it rarely happens that someone on this podcast actually studies, signal processing, because it's not a subject that you can study, everywhere. And could you maybe reflect how was it like, or what was the main, let's say, where was the main heavy point of the curriculum?
It was very math heavy, but so a lot of it kind of felt a bit. I was sort of overwhelmed by the abstractness of it, and also being in uni. A lot of that was sort of very much geared towards the telecom industry, because that were like the jobs were, and I was more interested in synthesizer filters and then things like that. But also, apart from, I also took courses in like image processing and things like that, because that's also part of signal processing. But in general, I think maybe one of the things that I felt was missing from, and this applies to the courses in programming as well, it's very theoretical and not very practical. It's like you feel you know a lot, but then you sort of, well, how do I go about actually implementing this in real time and in coding? You think, don't really. That part I felt a bit you had to figure out yourself. But maybe it's better now. I don't know. That was 20 years ago still, so almost.
I sometimes feel that, that when you're at the university, you feel like you lack practice, and then you go to work where you have a lot of practice, and then you feel like you lack theory, and it goes like in circles. Maybe we should find a way, to interleave somehow work with university somehow.
Yeah.
Yeah.
What did you study at university?
So I studied acoustic engineering, also out of this interest for music. And also during my studies, I started to enjoy programming more and more. So to me, it was like I started programming, and then I learned, how much I don't know about computer science. And I wanted to also study computer science. So I did it like as a double degree, or like, on the side, I started computer science. And there, I knew the worth of the knowledge that was given, right? So I knew that this is something that is not worth much as for me as a programmer. But there were other subjects that I knew were, priceless.
Yeah.
So so
you have a double degree.
I wish I had. I did two years of computer science, and then I moved abroad to do master degree, and I decided to drop the computer science. So, like, long story short, I could return there during the pandemic, but I decided that I don't need it anymore. So, like, what I got out of it is to my benefit. The rest, I won't get the paper, but the knowledge is still there, and I definitely don't regret it.
No.
So I'd guess that after, when you weren't working after the university, you went also to the telecom industry.
Yeah.
Okay.
No, I did actually. I came out. This was during the 2008 recession, so it was really, I know I went to like the job market fair at Chalmers, and it was like, no, sorry, we don't have any jobs. But it took a while, and eventually like started to get replies to applications that I sent. And it's always like getting the first job is always the most difficult. So, but eventually I found a job as a consultant, and I started working for Ericsson in Gothenburg. Did that for a couple of years. And then I had some bit of a, life crisis, and I wanted to do something else. And I had some wild plans of, I want to move to Berlin and like work for one of the big music companies there and something. But that didn't happen, and eventually I ended up moving to Stockholm instead, which was, I think it was a good move. I reached out then to a few of the like music tech companies in Stockholm, but things didn't really work out. So I got another consulting gig, and I worked that for a few years, like 4 years something. Until I again got to the point where I felt like I wanted to do more work with something closer to my passion. And I was looking around and that's quite like a funny story actually, but it was actually my girlfriend who found the position first, because she was on the EMS, the Electronic Music Studio in Stockholm, their email list, and then there was a post, we're looking for someone with like experience in audio, in C++, blah, 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 to do this crazy guitar thing. And I was reading it and I felt, check. I need to apply to this company. So I put together an application and I sent it, and then I got a reply the same day from Stefano, the CTO at the company. It's like, hey, come over and we'll talk. And they liked me, and eventually they hired me. This was what is now called Elk Audio. It was called Mind Music Labs at the time, and we were doing this really like crazy guitar with like it's a built-in music studio and like sensors, accelerometers, and stuff. So that was I really sort of coming from playing the guitar. I really felt I want this guitar, and yeah, it's been a ride since, but that's how I ended up there. It was like the right thing at the right time that just sort of dropped in my lap. And I think it's funny. I've had it with several friends of mine that I've seen, like they're looking for jobs, and eventually they sort of, by random chance, they end up at a place that just suits them. In many cases, like audio companies. But I remember after was the first or second year, and we were in Stockholm, and one of the CTO and another guy from one of those big Berlin companies came to visit us, and I was like, yeah, here I am sitting and talking to them, and it feels like I've gone like full circle, but still ended up like in the position, the place I wanted to be. So
awesome.
That was pretty cool.
Yeah, so it sounds a lot like, a dream come true, and I think, the fact that you've stayed there since 2016, so it's almost 8 years now, right?
Yeah, it's almost 8 years.
I think it speaks to the fact that it was meant to be. So
yeah, it's quite crazy when you think about it. I've never had a job that long, and this was a startup that I don't know how we've survived all this time, but
yeah, but I also think like in the let's say regular IT industry, like people work way shorter times than 8 years. So I think it's an amazing testimony to how how you fit into the company, so to say. And
thanks.
I'd like to just ask maybe one technical thing before we jump on this guitar. So in your previous jobs, you were working primarily in C, or which languages did you use?
C and C++ mostly. Like my first job, I was actually writing network drivers for Windows. That was mostly C and quite close to the operating system. Then I wrote mostly C++, a bit of Python.
Okay, and did you also learn C++ at the university?
No.
Okay.
We had Java was the main language but now I've forgotten most of the Java code, but it was more like a base. I think maybe it was a good language for learning like basic object-oriented concept, and we would like typical algorithms and containers, like write your own linked lists and things like that. But no, C++ I've learned on the job, so to speak, mostly.
Okay, nice. All right. So could you then please tell more about this guitar project?
Yeah. It was called Sensus. We did a pretty cool promotion video. We can.
We'll link to it.
It's a guitar with a built-in like sound studio, and had a lot of sensors. And the founder of the company, Michele, he was a luthier, so he's a classically trained guitar builder. But he had this vision of the guitar for the future. But I really wish that eventually we would have made the guitar, but it's not. It feels like it's not happening tomorrow. Now we're very much focused on Elk Live.
So it somehow got sidetracked then?
Yeah, we were building this which was our next product, the Elk Audio OS, which was actually it was the platform that we built for the guitar. It was a very ambitious embedded platform that we made for the guitar. But then when we were talking to people, we realized that they were more interested in actually using the OS than guitar. And we felt that this business is better than it has potential to scale better.
Okay, and so what were the features of their guitar, or the completed or the planned ones?
The completed, I try to remember. It was like a regular guitar. It was 6 strings, and you play it as normal, but it had pressure sensors on the front. It would have a ribbon controller on the back of the neck that you could play with your thumb, almost like a 7th string that you could play like synth sounds on it. One thing that I thought was really cool was it had an accelerometer that you could map to the specific effects. So you could trigger effects, so you can control filters just by the way you would hold the guitar. So it's very like a performance instrument in that sense.
Oh yeah, I can imagine. It's like really awesome that you could, like, for example, raise the guitar, right, and then have some kind of effect. Yeah, it's really, really cool. And did I also get it right that it was supposed to be used by Muse as well?
Yes, it wasn't actually that guitar, but there was.
Okay.
When was this? It was a kind of a collaboration between us and Arturia and Fishman. So what we put together was basically, the Fishman has this triple play. It's a MIDI pickup. It's a pickup with built-in pitch detection, so it sends MIDI. So we took that and we bolted it onto our platform, running Elk Audio OS, and then we had an Arturia plugin running inside our platform, inside Sushi, which is the main DAW in our platform. So it wasn't our guitar, but it was like a custom-built mini version of it.
Okay.
But it was made for Matt Bellamy of Muse, and he played it on stage, which was pretty awesome.
Yeah. So
he could play a synth in the guitar.
Yeah, so it's definitely something that you can see the result of your work on stage. That must be pretty spectacular. Have you also played with the guitar yourself, like for fun?
Yeah, I've played with it. It's fun. That's also one of the things that like working at a small startup, like you need to sort of be able to do things on the fly and just drop everything and do something for it. So there was one time I had to fly to Berlin to demonstrate the guitar at some event there, which is pretty fun. Yeah,
I can imagine. Okay, but now you mentioned this Elk Audio OS, and I think that people who attended the Audio Developer Conference know about it already, but could you maybe, for everyone else, give a brief introduction to what it is and what is it for?
Yeah, it was 2019, I think we sort of revealed it at the ADC, the Audio Developer Conference, where we had a booth and we had talked about it. But it was essentially a custom-built Linux application, Linux distribution, I would say, using a dual kernel setup to get sort of the best of both worlds of a real-time system and a non-real-time system. So you will get like the hard real-time performance of something like a DSP chip or a running bare metal, but you could also get the full benefit of running a Linux distribution where you can have support for all kinds of devices. You can have networking, you can have just USB plug and play, and a lot of fun stuff. And we've also built on top of that a lot of like supporting software. We built a real-time oriented full DAW that could hosts VST plugins and LV2 plugins. So the idea was sort of to bridge the gap between hardware and software. I think if you were a software company doing plugins, you should ideally just be able to take your code that you've written, maybe in Juice or some other framework, recompile it for the Elk Audio OS platform, put it in a box, put some knobs on it, and ship it, and you have a hardware unit. And also you can have a software version and a hardware version running basically the same code. You don't need to support two versions of the same code. It's all the same.
Nice. And can you tell us maybe a little bit what were your responsibilities when working on Elk Audio OS or Sushi?
Yeah. I'm probably the biggest contributor to the Sushi code base. Back when we started, it was me and Stefano, the CTO of the company, who were programming, and eventually his responsibilities drifted more towards CTO things. So I've done a lot of the real-time stuff on Sushi. But that was that was an interesting thing, because back when we started, I was looking around to see how many open source DAWs there are, but there weren't that many at the time. There was basically one or two that I could find, just to sort of, because I came from having not really worked with audio to, now we're going to write the DAW. It's a quite ambitious project, but how do you do it? So one thing was, of course, to sort of get used to the sort of specific intricacies of doing audio coding, or it's real-time safety and hard real-time guarantees, and you can allocate, and you shouldn't do amortized complexity and that kind of thing. And sort of how do you do juggling communications between a backend that runs in a non-real-time part and a real-time thread that just keeps running. But eventually I think I had to learn all those bits. I read a lot of blogs. I went through the whole archive of the KVR developer forum, which is a great resource.
So exactly, that's my another question of mine, because you came, you had the basic in signal processing, which is already a lot, but then you came from a little bit different background to the audio industry, and that was exactly one of my questions. So how you learned this C++ / real-time programming stuff, and apart from the KVR developer forum, are there any resources particularly that you could mention? Do you remember the open source DAWs that you mentioned?
Yeah. What was it? Ardor was one that I looked into quite a lot. And I also looked at the code of things like Super Collider. There's one called InGen also, which is, I think it's made by the same guy who does the LV2 plugin format. Ross Benzina's blog, also read a lot of. But it was interesting. I came from, I didn't have to learn programming, but I had to learn the specifics of more audio programming. But it was also when I started, it was I said, it was me and the CTO of the company, Stefano. And I remember that we had both worked on code bases that were quite, should I say, not of the highest quality, and we've sort of seen the worst, and we both felt that we had sort of similar visions of now we're going to build something from scratch, and we're going to make it it's going to be good. We're going to use it's going to be unit tests from the beginning, automated testing. We're going to make it modular, nice, structured into functions. We're going to use all the sort of latest and greatest versions of C++ and guidelines. And we read the CPP core guidelines and things to sort of what is the sort of best way to write C++. So that was quite, and I think, judging from the other places I've lived on, I have to say that I think we still, to this day, we have a pretty high standard, and the code is nice. It is well structured. It's easy to read and then easy to work with.
Nice, because that's really hard. And I also appreciate that you mentioned unit tests, because I get the feeling that a lot of people in the audio space, they say, yeah, like you cannot really test audio, but it's always great to hear that you actually can. So there are a lot of things that you can test and you should test. So
you should, I mean, you can definitely test audio. It depends on a little bit on what you sort of want to test. I mean, for Sushi, which is our DAW, it's not so much audio in terms of DSP. Like, for having actually studied signal processing, I've done very little actual DSP at this company. A lot more of just infrastructure to host other people's DSP code. And that bit is easier to test, I say. But definitely it is hard sometimes to test things like communication between non-real-time and real-time core, and things has to go back and forth and so. But I think one thing I find, if we at the detour, I mean, with unit tests, that I think just the fact of having unit tests or writing code with unit tests in mind, writing code thinking that this needs to be unit tested, it kind of forces you to write better code, like code that is more structured or more separated into like individual modules that you can test. And I remember a story I can share from before I worked at Elk as a consultant, and I worked at a company. I made this data recording app, and I spent maybe a month on it, and I did it without doing any unit tests because I figured I want to get it done. And then a few months later, I got some time to work on this again, and I was like, yeah, I'm going to spend some time actually writing unit tests for this because it's going to be good. It's good to have. And then as I was writing the unit test, I kind of realized that everything is like intertwined with everything. So it's very difficult to actually like take one thing, take it apart and test it in isolation. So what it forced me to do was first just refactor everything so that you have more like logical modules that you can then test. And I think now, after having worked so long with it, it's in the back of my mind most of the time. So maybe I don't need the push of having to write unit tests. But it was a really good lesson that if you write code with unit tests in mind, your code is going to be better and more modular and easier to work with.
Yeah, I could not agree more. And I've seen also personally many times, I think the simplest example is like using file system or networking. So if you write some code that, let's say at the end should, do some networking request, right? To store something in a database somewhere, then if you're writing this code with unit tests in mind, it's very obvious to you that you need to provide the kind of interface that allows you to, in production, do this networking call, but in tests to fake it, with some other class.
Sorry,
the connection broke.
The connection broke. You're back again.
Okay, so let me repeat that. So let's say that in your code, you need to write some code that does some networking call, for example, to store something in a database. And if you're writing the business logic with unit tests in mind, then you make sure that this networking is abstracted out, so you can fake it in tests, right? And you can pretend to be doing networking calls because you don't want to be writing stuff into the database. But if you don't care about unit tests, then you'll strictly embed this networking call in your business logic, and then you're really screwed because to unit test this, you really need to build this out, and the same fact applies to managing the files on the disk. That's also what I've seen. Like you have a class that's doing business stuff or something musical even, and then it writes to the file system directly, and that is super hard then to test, for example, because on Android to write something to the disk you need permissions, so your app needs to be installed and you need to give the permissions and so on and so on. So this gets really
whole layer
really
of complexity.
Yeah, exactly.
Yeah.
So I totally agree with this, and I also think that C++ core guidelines are a great resource. Although that at times it's very interesting then discussion because they deviate a little bit from, let's say, the clean code approach that is promoted by Uncle Bob, right? So like by Robert Martin. And because it's C++, it's not Java. So it's I think it's a very interesting discussion, but it's definitely a great resource. And maybe on this fact, is there any C++ code base? And this can be audio. It doesn't have to be audio that you find particularly, I don't know, inspiring or like a good example of clean code. One that is available for others also to read.
Oh, good question. I don't know if I have anything. I haven't. I know that people have said very good things about the Juice code base. That is has a style which is quite verbose, but sometimes maybe I find it a bit too verbose. But it's very easy to read. But also on your point about like the database and unit test, I mean that's very. Even if you eventually at some point you decide you want to swap out the database for another type of database, like if you just embedded that database and its API in the code, then it's going to be really hard. But if you've just factored it out to an API, then it's usually very easy. I mean, that's one thing we actually, when we started working on Sushi, we sort of had that in the back of our heads. So we worked a lot with like front ends and back ends for different things. So that's Sushi has this like if you're interested in the architecture of Sushi, there's a ADC talk from this year or last year, but last November. My colleague Elias Bergström has a talk. It's a great talk if you're interested in all the details on it. But basically, that there's a core audio engine, and on top of this, there's like a audio front ends and back ends for different things. Like when we were writing for our embedded platform, we had our own audio API. So we wrote a front end for that. But then it's like, we want to run it on a Linux machine. Like, but we need a Jack front end. So we'll write a Jack front end. And then eventually for Elk Live, we wanted to, but we need to run on a Mac as well. Okay, yeah, but we'll just write a core audio front end and the whole thing runs on Mac. But there's a different MIDI. But we write a different MIDI front end. So it's like very modular. And I feel that was a design decision or architectural decision we made very early on that turned out to be a really, really good one.
Awesome. It exactly seems like some pre-thought paying off.
Yeah.
and I could not agree more. The talk by Elias was brilliant. I also put it in my top 10 talks of this EDC. Yeah. So I think everyone is waiting when it comes to YouTube finally to watch it. Yeah. And yeah, I watched this talk live, and I definitely be going back to it for more and more a reference.
I'll tell him you said that.
Yeah, please do.
I will.
And I have yet another question to this, because developing a Linux distribution is something that's super abstract to me, And I'm super curious, how do you go about it? Because you need to develop an operating system, but to write code, you basically need another operating system to write it on. So what was your workflow when it comes to this part?
You mean the actual Linux, packing up the Linux distribution?
Yeah.
I wasn't the one doing it, so I'm not super experienced with that. But we used, I think there are basically two tools to use. One is called Yocto, which is the one that we used. And there's another one, I forgot the name of it now, but I think that one is simpler. Yocto is more advanced. But I think it's not that hard. It's more about writing recipes, which is like listing all the different, I want this kernel version with these patches. I want all of these packages, and then you just sort of package it all together. Like the things that we did that was custom was both like Sushi and some Sensus software and things like that, but also our own audio driver, because we had our own audio hat or audio sort of DAC that we would talk, and it would be a lot. I think it was an SPI connection, which is a serial connection that gives you a lot better, lower latency than using like a USB sound card, for instance. So the connection to the kernel was much tighter and enabling us to get even lower latency.
Nice.
But apart from that, it was more like, I think it's a matter of just picking the packages and libraries that you want and just putting it all together and building it.
Okay, thanks. And then when it comes to Sushi, like if you're developing Sushi code, then do you write it on Elk Audio OS because it's a Linux distribution, or you write it on some other?
I write
OS?
it on my Linux laptop, and
okay.
Nowadays I use, since a month or two back, I use Apple computers. But we kind of abstracted away all the stuff that kind of differed. That's also part of like the modular thing, that all the things that were like specific to the real-time kernel and that would differ if you run it on the embedded platform or if you would run it on a normal like Linux desktop machine. We kind of abstracted the way to a library called Twine, which is also open source, just like Sushi and the rest of Elk. That if you use that library, it has APIs for a few like sort of real-time building blocks, like condition variables and a worker pool, and some functions to query if you're in the real-time thread or not. And then under the hood, that has double implementations, one for a normal Linux system and one for the embedded OS. And now some of it has triple implementations, some for Mac OS as well. But that's sort of how we go about that. So most of the code that I write for Sushi and stuff, it's completely platform independent. I could write it on a Windows machine if I wanted to, I guess.
Okay, and then you can simply compile, run the unit tests on your local machine.
Yes,
and deploy it to Elk Audio OS only when you need to.
Yeah,
and then
that was sort of our selling point, that you would be able to write, instead of working with DSP chips and something, you could do all your plugin development and audio code development on, or at least 90% of it, on your normal dev machine with all the debugging tools and performance tools available, and then you just move it to the embedded platform and run it there.
Okay, nice. And maybe my last question on this is, can you debug, I don't know, Sushi or some other custom code from this that runs on Elk Audio OS?
Yes, you can.
So then you need to. It's
actually not
like,
that.
Can you connect through the terminal? Then
and you can connect through a terminal, and then we usually, for the Linux distribution, we build normal version and a debug version. And the debug version, or a dev version, it has some built-in tools. It has a compiler, it has GDB, and it has... so you can either do like GDB over the internet, or you can just log on to a terminal and do GDB debugging on the board. And
okay, so for example, you can I think I've done it once in Visual Studio Code that you can connect via SSH, for example, to the Linux machine in VS Code, for example, and then
I think even you can do it
visually step through. Okay.
Yeah, I don't really use VS Code, but I think my colleagues have used VS Code for that purpose. So
yeah. I know that you're always just using the terminal. You don't need all this graphics.
Yeah, I mean we're different as developers. I like using the terminal. I like even for things like Git. I've learned to use Git the terminal way, and then I feel like I know how to do this. I don't, but I also have friends and colleagues that prefer a more like graphic interface. It's like, yeah, some people like that. Some people like terminals. You seem like more of a terminal guy as well.
Yeah, I like the terminal. Especially, I get annoyed when these graphic Git tools, they do something under the hood, but they don't tell you this.
Yeah.
And I
you want to be in control. You you don't want to do this, but I don't know really what it's
exactly. Yeah. So that's also on this side. So this is a good maybe moment to segue into the question on which IDE are you then using for development?
I'm using CLion mostly, at least for all the C++. I've used a bunch of them, but I think CLion was the one that I stuck with since I started using it. I find it really good. A bit resource heavy at times, but I like it.
And Stefano is using NeoVim, right?
Yeah, I think he's much more of a terminal guy than I am. He's a really hardcore.
Yeah, that's the next stage. That's the next stage.
Yeah, we'll see if I end up going there.
Yeah, but at least you can ask him, if something doesn't work in your NeoVim config, then you have someone you can reach out to.
Yeah.
Okay. Apart from the things we mentioned so far, you also have this product called Elk Live, right?
Yes.
So could you tell a little bit about this as well?
Yes. Elk Live is something that we worked with during the pandemic. So it's kind of something that grew out of not being able to meet each other. But we had a prototype before that, but that sort of made it clear that we needed to work on turning this from a prototype into actual product. So what it is, it's a platform we like to think of it as a platform for musical collaboration. But at the heart of it is basically the ability to stream music with very little latency, and also peer-to-peer and back and forth, so you can set up a session and actually, like, if you and I were to try and play music over this video call session, it wouldn't work because the latency is a few hundred milliseconds or something, but we need to get it down to like 20, 30 milliseconds. So we basically did that. And originally it was based on the Elk Audio OS. And so it was a hardware box that you would plug your guitar or microphone into, and your headphones and your Ethernet cable, and it would take the audio, send it out to the network with as low latency as possible, and on the other side you would receive it and play it back. And then there was also a video chat with it, but the video was a bit slower, so it wasn't synchronized. So the audio was high priority, and also with much better audio quality than Zoom or Google Meet. And eventually originally we thought that we need a box with the Elk Audio OS platform to be able to get like the lowest latency. But eventually we started testing and realized that you could actually run it on a real like a music production computer, like through if you have a good music sound card. So now it's actually we're focusing on the software only version that we're releasing version 2.0 of, I think around now, and eventually we will also release a plugin. So now it's a standalone program, but there will be also a plugin that you put in your DAW, and you just send the audio you have and you send it to your friend or your friends, and then you get their audio back. So it's the perfect tool for audio collaboration.
Nice. It definitely sounds like a big step forward. And can I ask, how does it compare to other solutions on the market? So I think I can think of at least one other company that does something like a music collaboration over the internet, but I'm not so much in the space, so I don't know what's the difference between your product and their product.
I think ours is definitely is the fastest. Definitely with the hardware, it is the fastest and most. I'd maybe say almost the most reliable. Not all of them have a video chat. Also, ours do. But I think I don't. I think this is an area where it's popping up new companies because I think it's something that's coming. So I don't have a full picture of all our competitors either.
Okay, I understand. And maybe before we move to other topics, because like the products that you worked on within Elk Audio, and in general the whole suite of Elk products seems very very technical to me. It's not something that you can easily write on your own, and it's requires a lot of knowledge. So could you maybe describe some challenges that you personally encountered during development and how you overcame them?
Yeah, sure. I mean, for Sushi, a challenge was definitely to do everything in a real-time safe way. That was sometimes you had to sort of work on some tricks, because also running on this embedded platform put even higher like real-time restraints than if you're writing a plugin that would run on a laptop. Because the worst thing that could happen there was that you do a lock or something, or a malloc in the audio thread, and but there's a glitch because it took too long. But on the Elk Embedded, there were actually things you could do that could actually sort of crash the system if you did it in the audio thread. So it was a bit more. You had to be a bit more careful. It's like, no, you cannot have any allocations or any locks, never. So a lot of like, but how should you, if you insert a plugin in a track while it's playing, how could you? But you actually need to sort of construct the plugin, and you need to pass it in an event as a pointer, and then through a queue, a lock-free queue, and then at the beginning of a process block, you need to insert it into the track, into the audio graph, and then you also need to do a bit of like audio ramping and things, so that the volume doesn't change abruptly to get it smooth. So all of those little things. I think for Elk Live, one of the biggest like technical challenges was to make it work with like all combinations of ISPs, of routers and firewalls, and like networks and God knows what. I found out that this shitload of different sort of configurations, and all these methods to do this like UDP hole punching to be able to, because we want it to be peer-to-peer for the lowest latency, but that's not always easy. And I found out that there is actually like a very rare combinations of networks where you actually cannot have peer-to-peer. You need to have a turn server, another server to actually bounce the messages off. But in 99% of the cases, you can do peer-to-peer with, but what we ended up doing was basically like a list of different like techniques. You try this, you try this, you try this, and eventually something is gonna work and enable you to set up a connection. But that was really, I think, one of the big challenges early on. And also do it in a way that is easy for people to set up. And you don't want to ask people, hey, but you need to log into your router and configure it so you can open these ports. But yeah, you can't ask everyone to do that.
Yeah, I totally agree. And it sounds a lot like, one thing is the technical difficulty, but then you need to also put another layer on top that allows easy usage. So like a layer for good user experience, right?
Yeah.
Yeah. So
definitely it needs to be easy to work with.
Yeah, exactly.
Even for I mean, it's easy to think that to think of yourself and you think you're pretty tech savvy and I can do this, but most people are not even if you log into my router, I don't know, how do I
exactly
do that? And it needs to, but also for us, I mean, we want things to work as smoothly as possible.
Yeah, exactly. And but even if someone is tech savvy, maybe they don't want to spend as much time setting things up.
Yeah, exactly.
Yeah. So one thing that's also occurred to me is that since you are writing a digital audio workstation, one thing that you need to ensure is that you need to handle a lot of plugin formats. So you mentioned VST 3, right, and LV2. And could you maybe share how you went about implementing the host side of these plugins?
Yeah. I worked mostly on VST3. I did most of that. A little bit on VST2 and LV2 also. But they're a bit different. I think VST2 is it's the simplest out of those three, definitely. But it also has its little challenges. VST3, I think the VST3 SDK gets a lot of flack for being like a bit over-engineered, and it is. But I do understand why they made some of the design choices that they made, because it enables you to have basically a C++ API that is ABI compatible with whatever compiler or something, because that's the reason. The ABI issue is the reason why plugin formats are at the low level just plain C, because with C you can have ABI compatibility. But they also have these it's not just an SDK. And one of the things that I had some issues with was this. They have this COM-like model where you have reference counted pointers that are smart pointers, but they predate the smart pointers in C++11, so they work almost like a stud shared pointer, but not quite. And it's like in that difference where they don't really work the same that I've had a lot of problems. Because at one point I assumed it works this way, but then no, it doesn't work this way. And then either I got like a double delete, or sometimes I just got memory leaks because they weren't objects weren't deleted as they should have been. But it was. I mean, VST3 is I think it's a complex SDK to work with. And there's a lot of, if you work with Juice, I think it gets maybe simpler, because Juice only uses like a subset of the whole VST3 API.
Okay, yeah, that's a good point, because there's probably a lot that people are not even aware of that there exists. if they cannot use it. That's a great point. And then how do you even go about writing a host? Like, I understand you need to read the documentation then from the SDK provider. Is that right?
Yeah.
Okay.
That's but VST3 was quite good because the SDK provides a bunch of like helper classes for the host. For the VST2, it's just the raw API. It's nothing else. And they have this C++ wrapper classes if you want to build a VST2 plugin, but for the host side, you basically have to implement the raw C API.
Okay.
The VST3 is a bit. It gives you a bit more code to help you do that. But typically, if you would write a DAW, you would do you would most likely have some sort of processor class, and then you would subclass that for different plugin APIs. As we discussed earlier, having APIs and having a modular design where it would be easy to write support for another plugin format. You just write another adapter class. And then you hope that the subset that you have, like some plugin APIs don't support maybe all of the functions that you need. For instance, like I don't think that LV2 supports like dynamic sample rate changes, for instance.
Interesting.
And then how are you going to do about that? Okay, maybe you need to actually reload the plugin if you change the sample rate, which you don't do very often. But yeah.
Okay. Yeah. So that's definitely I think because there are, as pointed out already at ADC, there are not as many DAWs out there. So I think it's pretty big challenge to write a DAW on your own. But it's good that people do this.
It is
in various contexts.
Yeah, and now for Sushi, we've only we've written a DAW. We say that we've written a DAW, but it's more like an audio engine. It's like a DAW that's very focused on real-time processing, and it has a timeline, but it's a quite basic timeline. But it doesn't have like a full-fledged DAW would have like clips, and you would have tracks and recording and time stretching and the whole graphical UI and then all of that. And that probably takes a lot.
Exactly.
A lot more time to develop. I mean, you were at Dave Rowland's talk also at the ADC, like why you should know, which is kind of fun and tongue-in-cheek. But I mean, he makes a lot of good points that writing a DAW from scratch today it's a big task. Unless you want to, maybe you have some unique idea, you want to write like a minimal subset of a DAW. But
I think that's why you also referred to Sushi as a headless DAW, right?
Yeah,
it's a headless DAW because it doesn't have the graphical user interface. Yeah, but I think it's still a complicated task.
Definitely.
Okay, so moving on from the topic of Elk Audio, I know that you also wrote your own plugin for the KVR Developer Challenge in 2021. Could you maybe share a little bit more about this?
Yeah, sure. It was something that I've always wanted because, as I said, for having studied signal processing, I haven't really done much DSP in working for Elk, but I want to do so. I'd done a bit of work on my own, like trying to write like a basic processing library and trying out some like plugin adapters and things like that. And then the KVR Developer Challenge showed up, and I was like, I thought maybe I should do something. It's good to have a deadline. So it was. I think it was during the summer, 2 or 3 months of 2021. But I had this idea. I was sort of thinking, I need to do something, but what should I do? But I had this it's a Roland, what's it called? It's a funny cat processor. The guitar processor I got from my dad. It's like a distortion and a filter. And I always said the distortion is kind of weird because it has more like a compressor than a distortion. And I figured, maybe I should try to clone that one because I don't think it's been done and it's kind of a weird effect. So I thought, I'll do that. So that was actually, once I had decided, like if you have a pretty tight deadline, you kind of just have to decide and then you realize it's too late to change your mind. So you just have to go like all out and do it. And I didn't actually, the original box was actually in storage. So I didn't have access to it. So I built it kind of from the schematics and figuring out how it worked. But it was a fun project. And I like sort of minimalism, which is one of the reasons I didn't use Juice to build the plugin. I sort of wrote my own very minimal wrapper, which is maybe it's a good idea if you want to do something as a little like passion project. But if you're writing a commercial product, you should definitely use Juice because it's like all the sort of intricacies of some DAWs do it like this, some DAWs do this, and some will like Juice has you covered if you do that. But I thought it was fun to sort of roll my own. So I did that. Then also for the graphics, I used this immediate GUI framework called Dear ImGUI, which I thought was quite cool because they also have the same sort of concept of minimalism and the bloat-free, that it should be really small, nothing unnecessary. But it's basically, it's a different type of GUI than most like the Juice GUI code or the Qt or something. It's they call it stateful. And with immediate mode GUI, they said that the GUI should have a minimal state. So what that means is basically it's like instead of having a function, it has now a class for like a button. You have a function for the button. And if the function returns true, it means the button was clicked. If it returns false, the button was not clicked. But this also implies that you're redrawing the whole GUI at like your 30 or 60 FPS or something. So it has to be like OpenGL or Vulkan or like hardware accelerated.
Okay.
So it comes from the gaming industry, where then basically you have to do because you're redrawing the whole screen at every interrupt. So but that also means that like you can animate anything at like no cost because you're redrawing everything. But it works really well. There was a bit of work to get that to work in like a plugin where it's like you can have multiple instances and you don't own the message loop and things like that. But I think it turned out pretty cool. It's if someone is interested, you can go on KVR and search for it. It's some sort of mix between a distortion and a compressor, which it can also. It has this weird function where it kind of overcompensates. So if you have a big transient of like 10 dB, it might, if you set it to some weird combinations of setting, it will just, on the transient, will reduce the gain more than 10 dB. So it will actually cut more than your original signal. And then it just comes back up a bit. And then, so you get this, it was kind of, I didn't win, but it was fun to do it. And fun to also have a project where you have a pretty short deadline and just want to get something out there.
Yeah, I definitely agree, and I think it's also a nice challenge from the developer perspective, to not to use Juice nowadays.
Yeah.
Yeah. So which formats did you support?
It was VST2 only.
Okay.
I think at one point I should, when I have time, but I don't have that much time anymore, but I should fix all the bugs and make a VST3 version of it. It's on my to-do list. I cannot promise when it will be done, but I want to do it at some point.
Yeah, you need a deadline, right?
I need a deadline, yeah.
Yeah, and is the source code available somewhere?
No, it's closed source.
Okay.
I haven't really decided what I wanted to do with it. So I've kept the source code to myself. Maybe at some point I will open source it. I don't know. We'll see.
Okay. Yeah, it will be always interesting to see. Let us pause here for a moment. In the answer to the last question, Gustav mentioned the Juice C++ framework. What is Juice? Juice is an open source, cross-platform C++ application development framework that makes it easy to create audio software as well as audio plugins and plugin hosts. You can write code once and build VST, AU, AUV3, AAX, and LV2 plugins on Windows, macOS, iOS, Android, and Linux, as well as embedded platforms. I've been successfully using Juice since 2018, both in my private and professional projects, so I'm delighted that they're sponsoring the podcast. I especially like how Juice makes it easy for beginners to jump right into creating audio plugins and applications without worrying about C++ quirks. Juice is used by the majority of the world's most important audio companies, but it is free for personal use and there's affordable pricing available for companies just starting out. Apart from the framework itself, Juice has an amazing community of users gathered in the Juice forum, which is a great resource to learn audio programming on its own. To start using Juice now, go to juice.com, juce.com, download Juice and follow their Getting Started guide. I have also put the link to it in the description. Have fun creating audio apps and plugins. And now, back to the interview. Okay, another question I have is we are circling around this C++ Audio Developer Conference topic, and you've done, I think, 2 talks so far. So one with Ilias and one a standalone, right?
Yeah.
And in particular, last year at Audio Developer Conference 2023, you did a great talk on optimizing DSP code. So could you share maybe where did the idea for this come from?
Yeah, sure. I mean, thanks for that. I'm really happy with how the talk turned out. I'm really happy that you and other people enjoyed it and found it interesting. As I said, I've been interested in like optimizing things and sort of what happens under the hood ever since I got into like audio programming, and also for how to all these real-time safety things, and to make that, to enable that, you kind of have to know sometimes what's actually happening under the hood when you add elements to a vector or how different. So that was kind of interesting. What happens like below the code, or what happens? So it's something that I've always been interested in, you say. So a few years ago I wrote some articles for Elk also on different like stood algorithms and how they would compare in a like audio context. So I had this sort of vague idea of what I wanted to do with the talk, like, and I felt that kind of that angle of approaching optimizing, but using the compiler and not trying to write assembly code and stuff, that was something that hadn't really been covered that much. But it took me quite a while to sort of going from a vague idea and just writing an outline to actually sort of putting the full talk together. And I want to say also a lot of things, there were definitely some things that I learned as I was preparing the talk. The whole, if you remember, there was about the restrict keyword.
Yeah.
That was something I actually figured out. I thought that, this improvement actually comes from reducing the number of memory allocations and memory reads and writes. But it actually mostly came from reducing aliasing and allowing the compiler to optimize things better. So definitely, I mean, you learn something when you put together a talk like that also.
Okay, and do you remember which resources did you use for preparing the talk?
I used a lot of Compiler Explorer and like measuring things with Google Benchmark mostly. Sometimes with my own timings and using things like Valgrind, but Google Benchmark was pretty useful. But I definitely Compiler Explorer I would recommend to anyone who's interested in like what's going on behind the scenes, because I think it's a great tool. You just write your code and it just spits out what the compiler sees it as, like the assembly code, and you can see. And as I mentioned in the talk, you don't have to be that good at assembly code. You can usually spot patterns and stuff quite easily.
Okay, and then if you really want to learn assembly, because that's the bit that I always get a little bit problem with. So I opened the compiled code in Compiler Explorer, but there are some commands that I understand in assembly, but most of them I don't. So then you Google for the specific commands, or
sometimes I've done that.
Okay.
Sometimes, but I think Compiler Explorer has pretty good, like you hover over it with a mouse and then it.
Okay. So you mean that it highlights the code that it's responsible?
Yeah, it also does that. It's quite cool. Every line of C code is, you see what assembly that it's probably not 100% perfect, but I think it's pretty good. But I don't know assembly code, so I shouldn't. Sometimes you can Google, you can get an idea what it does, but if you get an idea, you can probably guess a little bit and fill in the missing parts.
Okay, I understand. And I think that also your talk was very valuable in that you, at the beginning, I remember you said that you're not an assembly expert. And that's what a lot of people new to this field fear, that they need to know assembly. And C++ is daunting enough for them.
Yeah.
So I think it was a great benefit.
Yeah. Oh, awesome. You definitely don't have to know assembly.
Okay, and while we're at this at the topic of writing C++ code, a lot of people, come to this field and they are curious, like, do I have to learn C++? Should I maybe learn some other language? And if so, then how do I learn, this real-time C++ programming? How do I write fast C++ code? And is there any advice, any thoughts you have in this area?
I mean, I would say to be an audio developer, it doesn't necessarily mean to be a C++ developer. I think there's or a real-time audio developer either. There's definitely like most of the things that I write, and I think maybe even more so at a bigger company, is things that aren't specifically like audio related or DSP related. Most of it could be like for the same kind of coding you would do in any other company. And like in Eddie, if you have a big company like Ableton or Native Instruments, I guess like 90% of the coders, they're probably working on other things than the audio engine. Like graphics and GUI and networking and a lot of these things you can probably script with Python or Lua or any other kind of languages. So you definitely don't have to learn C++ to work in the audio field. But if you want to learn C++, good question. I used to read a lot of blogs. I watched a lot of talks on YouTube, like from CPP-Con and stuff. That's usually very interesting. You can read books is also good. I mean, which you tend to think of this digital age that everything is on the internet, but it's actually sometimes it's good to just sit down with a book. I read one of the Alexandrescu books a few years ago over Christmas, and it's quite challenging to sit down and actually just read it and try to. It took like one chapter per night, but it was a good read and trying to sort of visualize the whole thing. But
yeah, I'll definitely agree there because I really like books. So
yeah, but I mean, this you do learn more. Actually, you remember more if you read it on paper than if you read it on a screen. It's this
that's
research
point
to support that.
Okay. Nice. But is it because you're reading it slower, or is it unexplained? Why is it like this? If I read the same book but in a digital form, would it stick more as a paper book?
I don't know. I would think so, but my guess, without actually knowing, is that it probably has to do with you being more easily distracted on the screen than on a book, on a paper book.
Yeah, that's true. There are more elements on the screen.
Or maybe you just read books in a different situation. Like you sit down and read a book, and then but things you read on your phone or on your computer, you read it on the subway, or you read it while you're waiting for something for 2 minutes here and there. I don't know.
Okay, I understand. Okay, and my last question on the ADC is that what is your general impression of the conference? And would you recommend other audio developers to go there?
Yeah, absolutely. I mean, it's definitely the place to be. It's the biggest gathering of audio developers there is. And if you want to get together and talk about all these nerdy things, it's the perfect place to be. But I mean, I've met so many people. I wouldn't be here talking to you if I hadn't been to ADC last year. And so it's been there like 5 times or something now. It's been
nice.
I remember the first time I went, that was probably 2016, the first year. Me and Stefan went there, and I really felt, I'm a bit lost here. And it was quite small at the time, much smaller than last year. But I remember thinking also that, it would be really cool to kind of have to talk at one of these events. But I was like, what do I have to say? That was really my feeling. But I mean, that's something people should keep in mind if you think if you're new to the whole audio developer stuff and everything feels overwhelming and the learning curve is steeper than Mount Everest. It's like just start somewhere and you will learn a lot, and eventually you get to the point where you actually have something to contribute to an ADC talk or something.
That's I really agree. Yeah,
but it's definitely it's my favorite software conference that I've been to. Definitely.
Nice. And which other ones have you been to? Any ones that are known, or are there more?
No, I haven't been to any of the big ones.
Okay.
I went to a Python one here in Stockholm, and a few small ones. But
okay, yeah. So I think I that agrees with my impression, but it's also like very interesting to see how various conferences are approached and how they differ. But ADC is a lot of fun and super intensive.
Yeah, it is. You feel really like talked out and tired from that, but it's good fun.
Yeah.
So everyone should go.
Okay. As I also understand, you're a music producer, and as you said, you're also a musician. So, do you have any musical portfolio on the internet? Can someone listen to your music somewhere?
Yeah, there's some stuff on Spotify and then on SoundCloud.
Okay, and Like, do you still find time to do this, and how do you approach this?
Like the last couple of years, I haven't had much time. So then the ambition has been more like, okay, if I can record 30 seconds to put up on Instagram, that's enough. But it's I feel at some point I should really try and record something again. But I'll see. I'm actually going this weekend. I'm going with my brother and a few other friends that we used to play together at uni. So it's sort of his 40th birthday present. So we're going there, a bunch of jam dads, and we're gonna jam and hopefully record an EP. That's the plan, at least over a weekend.
Nice,
So
nice. And does it also allow you to kind of, disengage from work, some kind of relax?
Yeah, definitely. I mean, playing the guitar sometimes is a good way to relax. But I think from disengaging from work, I think exercise is more of a better way for me to sort of disengage from work. I go running or cycling in the summer.
Okay, nice. And how often do you do, or how regularly do you jog?
To jog depends on how ambitious I am, but maybe 2 or 3 times a week.
Okay, nice.
Things like that.
And how long is the distance on the average, if it's consistent?
Consistent, maybe between 20 and 30 kilometers per week, if I'm not.
That's a lot.
Yeah, it's, to me that's kind of normal, but I've been doing it for some time, and you sort of eventually you start to think that was. I did my first marathon in September last year, and then I was preparing for that. I was doing like increasing. I went up to like 50, 60K a week.
Nice.
But then you get a bit. That's quite a lot.
Yeah, but I can imagine that it helps also your brain function better in general.
Yeah, it definitely does. I really feel that, especially now, like in the winter when it's cold and it's dark outside, and you meet your friends, you go for a run, and it can be cold, dark, or rainy or something, but afterwards you feel a lot happier. So it's I recommend it.
Yeah, it's definitely a great tip. And do you when talking about disengaging from work and music, do you also listen to music while programming?
That's a good question. I do quite often, yeah.
And what kind of music is this?
I think I tend to listen to instrumental music more than vocal music, especially if I'm doing something, or I'm coding something that requires a bit more concentration, and more, like, not too complicated music. Like, I wouldn't listen to Autechre or something really like complex. That would take too much attention. I think too much away from coding. More. There is this not a podcast, but they do regular mixtapes called Music for Programming.
Okay,
it's a website, and that's something I listen to sometimes. For
I need to check this
coding
out.
It's quite ambient-ish often, but it's pretty. I find this to be quite good music for coding, but I know that some people don't actually listen to music while coding because they find it distracting.
Yeah, that's true. I'm still undecided. Okay. But I feel like I focus better when I don't listen to music.
Yeah.
But then in the afternoon, if I'm tired, and it can happen that I'm also a bit tired, then I tend to use some music, even some more energetic music, to kind of, wake me up and stay in the zone.
Yeah, but sometimes you need that. You need a bit of something to pick you up. And
or if I have to do something super boring, then I need music, as at least this fun part of the thing that I'm going to do.
Yeah.
Because otherwise it would be really, really depressing.
Yeah.
Okay.
But it's good. You need to find time to listen to music also.
Yeah, that's true. That's true. And but it may be surprising, but it may also be challenging to find time to listen to music then. And what are then your plans for the nearest future?
Nearest future? No, I don't have any big plans for the nearest future, actually. We have some plans for work, but don't think I can share that.
Of course. And are you going to ADC 24?
I hope I am. I need to think of it would be fun to talk again, so I need to think of a good subject to send to the.
Yes, please do.
To the committee.
Because judging by your previous talks, it will be of great value. So yeah, it would be awesome.
Thanks.
To learn so much again in a single talk. So Gustav, thank you again for this interview. Thank you so much. I really appreciate your insight, all the resources that you mentioned, all the tips, or all the challenges that you needed to face. And I'm super happy that you can work, in an environment that is where you do things that you like, and you can focus on audio programming. And I hope that this journey with Elk Audio will continue for you happily into the future. And I wish you all the best for all your future plans, and especially with your little one.
Yeah. Thank you so much. It was the pleasure was all mine. It was very nice to be on the show. Very much nice to be here and talk to you. And I guess we'll see each other at the next ADC, I hope.
I hope so too.
Yeah.
So until then, take care.
Yeah, take care.
All right, everyone. That was Gustav Andersson, a senior C++ software engineer from Elk Audio. Thanks a lot, Gustav, for this awesome conversation. And I really hope we'll meet each other again at the ADC 24. And to you, dear listener, you can find all the people, places, and references mentioned in this podcast episode in the episode notes at thewolfsound.com/talk022. And if you would like to help the podcast somehow, you can subscribe to the WolfSound channel on YouTube and give thumbs up to this video. You can leave a 5-star review on Apple Podcasts and on Spotify. And if you'd like to see someone very specific on the next podcast episode, then you can suggest this person in the comments on YouTube or on the blog, so in the episode notes. And I'm very curious who you can have in mind. Don't forget about your free resource, so the audio plugin developer checklist at thewolfsound.com/checklists. And finally, thank you for listening, and see you in the next one. Take care.